Magnetism lesson number 2. To make things simpler, I've drawn some field lines and made them straight. We do know that they loop at times, but this is a nice visualization. So the lines themselves are basically straight. Now with electric field lines, we use the letter E. For magnetic field lines, the letter M has been taken for mass. So we use the letter B. So magnetic field lines are B lines. So if you've ever heard the term, B line to someplace, maybe it has something to do with this, but probably not. All right, now the next question is, once we have these lines, are there actual forces acting on objects in magnetic fields? And the answer is absolutely true. All right, to have a force in a magnetic field, a magnetic force, first we need an object. So there's a couple rules of thumb. First, the object must have a charge on it. So for example, if I was placed in a magnetic field, I'm uncharged. So therefore, the magnetic field has no effect on me. Let me get a magnet now and then try to force myself using a magnet, and nothing seems to happen. It doesn't stick to me or anything because magnetic forces do not act on neutral things. Charged particles, yeah. All right. Next thing, it must have velocity. So the object must be moving. So for example, this object, let's say it has a charge of 5 microcoulombs, and it has a velocity going this way in this direction, right? There will be some force acting on this object. If I also look, the force, the direction of the motion must be perpendicular to the field lines. So for example, if this charge were to be moving sideways, parallel or anti-parallel, no force. So if you look at the object, it must be at least crossing some of the lines as they go through to create the force. So if we look here, we've got a formula here for force, and I'm going to use a B down below for force magnetic. Yeah, B means magnetism. So we know that number 1, it has to be charged, so it has to have a Q in the formula. It must have a velocity, so I put the letter V in there, small letter V. And of course, if you want magnetic force, you have to have a magnetic field. So the formula is QVB, and that tells us the force in newtons for this particular thing. The units, of course, for charge are in coulombs. Velocity is meters per second. And B is measured in Tesla. All right, after Nikola Tesla, from the famous Serbian physicist. So B is measured in Teslas. All right, now there is one other situation we need to address. Let's suppose, for example, that the charge is moving in an angled manner. So let's say, for example, here we've got a charge that is moving, say, at a 45-degree angle to the field lines. So it goes over like this, so it has a velocity along that line. Is there force? And the answer is, well, sure there is. So if we look, can't we break this down into its x components and its y components? So if we look at the velocity in this direction, the velocity in the y, and the velocity in the x, isn't it still moving perpendicular? So we've got to modify our formula. The force magnetic is QVB, and then we use the sine of the angle, and it's the angle between the field lines and the vertical. So it's actually this angle in here.